Hey guys, so we're going to do another video today for your lesson. I hope yesterday went okay. I know some of that is kind of confusing, but if you're still confused on it by the time I get back, we'll try to figure it out or we can reteach it, whatever you need. I know you guys have lots of questions, which is good. But if you have more about it, we can talk about it more. But today we're talking about Lesson 32, which is simplifying and evaluating expressions with integers and zero exponents. So, kind of a refresher for you. So if we do 2 to the 4th, we know that's 2 times 2 times 2 times 2, which gives us 16. 2 to the 3rd is 2 times 2 times 2, which is 8. 2 squared is 4. 2 to the 1, which means it's just 2, equals 2, okay? But when we're talking about zero, a number to the exponent of 0 and negative, so if we do 2 to the 0 power, it's just going to be 1, okay? I know it doesn't make a lot of sense, but it's just like the identity property that we talk about in multiplication. It's just going to be a mirror, but if you ever see something to the 0, it's going to be 1, and we'll review over that rule when we get to it. Then if we have, let's say, 2 to the negative 1, we can't have a negative exponent. So what we're going to have to do, we have to flip it. So we're going to make it 1 over 2, okay? So putting the 1 over it makes it positive. Now if we do 2 to the negative 2, it's going to be 1 over 2 to the second, okay? So if we're going to reduce that even further down, we're going to have to do 1 over 4, okay? So something to the 0 power is always going to be 1. If it is a negative exponent, you put this number over 1 and then solve the exponent just like you would if it was positive, okay? So we're going to go ahead and read over. I'm on page 197. So it says negative and zero exponent properties. So the negative exponent property, for every non-zero number x to the negative n equals 1 over xn, and x to the nth equals 1 over x to the negative n. Wow, makes a lot of sense, right? So if we're talking about the negative exponent property, it's saying if we have x to the negative n, okay, which we just kind of talked about with our 2, it is going to be the same thing as 1 over x to the nth, okay? Because remember, if we flip it, that means that it is going to be positive. Now, if we have 1 over x to the negative n, it's the same thing. If we flip it over into the numerator, then it's going to change it into positive. So if we have 1 over x to the negative n, it's going to change over to x to the nth power, okay? So that is the negative exponent 1. Now, if we're talking about the zero exponent property, for every non-zero number x to the 0 equals 1. So if you ever have a number to the 0 power, it is always, always, always going to be 1, okay? So if you see a number to the 0 power, always going to be 1, okay? So we're going to do a few examples to hopefully kind of make a little more sense, okay? Also, something you need to remember, if an algebraic expression, it is not simplified if it contains an exponent in it. So if you ever get down and the last thing you need to do is an exponent, do not leave the exponent because it will be considered wrong. You need to make sure that you multiply it out and simplify that even further. So we're looking at page 198, example 1a, and it gives us x to the negative 3. Okay. Now, if we look back at our negative exponent property, we know that if we have a negative exponent, that means that we need to flip it over to make it 1 over the number to 3. Okay, because remember, flipping them from like our reciprocal is going to make this positive, and vice versa. If this was negative, if we flip it, it's going to make our exponent positive. So x to the negative 3 equals 1 over x to the 3rd. Now, if we